And with that, I would like to introduce Jason Dablow, and he is a cloud security ninja. He spent lots of time in the Far East up in the mountains learning things about cloud security that none of us have even considered yet. So he brings a lot of expertise to the table. I'm sure that you will find this session informative. We are very appreciative and lucky to have him. And with that, Jason, the show is yours.
Great. Thank you very much, Chris. So again, my topic is just about building an automated security fabric in the AWS cloud. And I'm just going to be talking a little bit high level to start on just about different concepts of what you can do to really take things in a different direction of what you might currently be doing in AWS or other cloud providers, and really put a automation layer on top of that. So when we have, really the problem that you're looking at when you're trying to manage all different types of tool sets within a cloud is, one of the main problems that you're going to have is trying to figure out different things as what things are happening, or, is things happening? Because if there's one thing that cloud does allow you to do is allow you to gather a whole bunch of data. So one of the big things is figuring out or sifting through all the data to figure out if things are happening. And then from that, also trying to figure out if what those things that are happening are actually bad. So by combining these two, really the problem comes down to, just one kind of centralized point, with that being humans. Now, don't get me wrong, some of my best friends are humans, but there are some shortcomings as, individual us being humans that we're going to have hard times dealing with. So for one, we're forgetful. Two, we make mistakes, some, more than others, some hopefully not at all. And then we also suffer sometimes from analysis paralysis, where we have too much data coming in, we don't know what to do with it. So on the opposite side of humans, what we want to do is actually get computers involved and have them process a lot of these information. Computer or systems, they never tire, they're always consistent, and they have very fast execution. This is another reason why they're going to inevitably win the robot war once they uprise, become human, and take over us all. But really, it comes down to successful security comes down to three different P's. So the first being people. You're going to have people that are managing your security within your environment. The next being process. You have processes in place like incident response, things of that process nature that you're going to be following when something happens within the environment. And the third being products, whether this is a open source or a consumer tool that you've purchased. These products are also going to be very effective in helping with a successful security solution. So any tools that you have deployed within a cloud environment, most often than not, you're going to have more than one. I rarely see anybody that's running less than 5 tools within an environment. So really, it's all about the tools and making sure that they're successful within your environment as well. So the first being, you want to make sure that data can actually get in the tool, as well as, you can actually get the data out of the tool as well. And we also want, when we're using, say, AWS services, the ability to orchestrate the data or this tool. Because what seems to happen is if you have a tool that someone has to sit at a machine and actually learn to take in the information and log into a console and use that for the majority of the day, that's a big burden on both yourself and your staff. And that tool better be very, very critical for what your operations are trying to achieve with this tool. And if you have, say, 10 tools, you might have 10 consoles and 10 people sitting in each of those. So this really calls for the orchestration side of things and the ability to automate the tools that you will have deployed once you move into a cloud environment. So again, this comes down to probably the last year and a half hottest buzzwords of DevSecOps, where you have your DevOps, your application building team, and you're including security in that team to really define your security practices, as well as building secure applications and things like that. So each one of, say, I'll call it a silo for this new development, so DevSecOps development team. Each one kind of has their own goals, so the developers are always excited that it built something new, whereas the operation teams is always looking at if things are happening, and then your security team is always, looking at everything very, very critically and making sure that the things that are happening, making sure that they're not bad or malicious from some type of an attack. So yeah, each one of these has kind of there is some overlap here, but each one has special considerations as they're looking through the environment. A developer might be interested if there was a bug or if there was capacity to run their applications, where operation teams would also be included in the capacity as well as performance decisions, and then the security would be looking at anything overall like odd behaviors or anything that could be compromising the environment. So let's talk about the concept of a security fabric. So the basic idea is we want to automate everything that we can, or anything that happens so quickly that it would be very tough for a human being to accomplish by their normal operations, so their normal day-to-day people, processes, and products. So I'm going to set a line at 1 minute here, and what we're going to do is say everything that happens longer than a minute, so 1 minute, 5 minutes, 10 minutes, even longer than that, we're going to call this the slow lane. And anything that happens quicker than a minute, we're going to call this the fast lane. And again, anything in this fast lane is where we want to achieve that automation, really building in those practices, because as things are happening so quickly over and over and over again, we want to make sure that we have sufficient processes in place so we can automate these to take action in an organized fashion. So here we are on the fast lane. So everything happening under a minute. It could be 30 seconds, it could be 5 seconds, it could be even faster than that. So we want to just make sure that, again, things that are happening here, we are tracking and we are logging. So in this instance, we have something, flags for an alert. An alert is raised, and that will kick off, say, our teams to start looking at this. So maybe in this example, it's the CPU was spiked at 99%, or it ran out of storage on a particular EC2 instance. All of this type of data can be gathered using CloudWatch in AWS. So as these CloudWatch events are occurring, first our operations team are going to determine if something is bad based on the alarms that are happening. But then we'll also have a security send-off or a notification for the security teams to determine if something, if this thing that is happening is also malicious. So is there a high CPU on your web server, but is there nobody actually logging in and browsing your website? So normally you would see these two kind of go hand in hand, whereas more people use your website, the CPU percentage would go up as it's serving more and more people. But in this instance, maybe you have your CPU that's still high, but there's no request going in. So that's again something that the security team would need to look at. And again, because we're looking at a fast lane, this could be happening over hundreds or thousands of instances, or all different types of alarms that we'll want to make sure that we can handle these automatically. Because as I just mentioned, these are going to be repeatable. You'll have separate alarms that are happening, and this will be an ongoing thing over and over. Now, I first started talking about the fast lane. So the fast lane would be anything that we want to make sure that we can automate within an environment. So things that are, any alarms, security, anything like that that we need to make immediate action on should be handled in the fast lane. Now, as we move up, we want to make sure that we're handling other features in the slow lane that doesn't need necessarily instant eyes right now. So this could be, say, aggregating trends or information that's happening across all these different CloudWatch events. So you might have, say, 1 day, 1 week, 1 hour trends that you can go back and determine, okay, was this a busy time in the past? Did we have, say, high usage in previous times that we can compare against in today's time, so we can actually make comparisons based on, say, past trends or information. Another thing that the slow lane is particularly useful for is evidence of compliance. You might be taking all of your CloudWatch logs and sending them off to Glacier to just be stored for an infinite amount of time until you need to, say, show that for a particular audit, whether it be PCI, NIST, any of the frameworks out there, really showing the evidence of compliance within that framework. So you can say if the auditor comes in, you have all of the information already stored in a safe place within AWS. So you can quickly bring that up and give that to people or the auditors that require that information. And lastly, you might have deployment data or things that are saved based on deployments that you've done in the past to give you really, again, information that's accessible as well as archived at any time from specifically into AWS services. So as I mentioned before, in the Fastlane, you'll have the operations teams as well as the security teams sitting in that Fastlane. They'll want to make changes to the environment, hopefully automatically as quickly as possible. And some of the AWS services that you might be using in the Fastlane are Amazon SNS, or Simple Notification Service. This allows Amazon services to process messages from different tools, whether it be security or deployment tools, and really give you feedback on bringing in the logging structure from those tools into AWS services so you can take additional actions against them. And as I mentioned, you also have CloudWatch logs as well as CloudWatch events. And you might also use Lambda functions, which are serverless scripting architecture. So I'll be showing a couple of use cases in just a few slides specifically around Lambda functions. But think of Lambda functions as you give your code to AWS to run. You don't care about the server that it's on. You don't have to worry about what operating system. You're just giving it a piece of code, and then AWS handles running that code within their environment. So this is great for, say, taking automated approaches against different things. For example, myself, I have basically a poison pill on my identity or my virtual identity. So if I ever, say, died or didn't log into a particular service in X amount of times, it will automatically send all my passwords to my family and loved ones so they can sort out my details after my death. That's kind of just one of the examples. I know maybe a little bit dark, but I guess it's still early. We can be a little dark while it's still bright and sunny out here. So that's just one of the things. You might also say run code that might take action as building more EC2 instances, like building a new auto-scaling group, or tearing down or rebuilding a particular instance, or even quarantining it to a different security group. So really, it's what you can do within Lambda is basically endless, from whether it be operational tasks in their cloud, or even things to help with your day-to-day life as well. And then up in the slow lane up above, what we're going to be, let me just go back. So there's a couple different things that we're going to be looking at specifically in the slow lane, again, for compliance, aggregate trends, things like that. We'll use CloudTrail, which logs all of the API calls within AWS. Also configuration rules, which can look at configurations, perfect for seeing audit to see the exact configuration at exact time, perfect for that use case as well. And then again, you'll also have an overlap of the CloudWatch logs to actually get the information of what's currently happening within your environment as well. So here we have a couple of use cases that I have actually customers have implemented within their environments. So the first being, this is just my first talk really about the Trend Micro product Deep Security, which is a hybrid server security platform for your server workloads wherever they happen to exist, whether it's a virtualized platform, a physical server still left in your data center, or new EC2 workloads out in any cloud. So we can manage this all from a single console. And one of the nice things about our console is we give the ability to export events out to Amazon SNS, which again you can take action on via Lambda functions. So one of our customers, a top 10 global retailer, who is securing multiple servers both on-premise as well as out in AWS. They have a very large presence, and they want to automate things that are occurring based on malware events. And this was approximately a year and a half ago when they implemented this, so it's gotten much, I would say, more complex on what they're monitoring for, but this was their first idea on what they should be looking for in terms of automation within the cloud. So what they have is their EC2 instances that are sending data through the deep security that's protecting it. Through an SNS, the anti-malware event is being sent up into AWS via SNS, and then they're taking an action on this malware event. So was it cleaned, was it quarantined? If it wasn't, and it's still, say, an active infection within the environment, they'll take additional Lambda actions against those by, say, rebuilding it from the latest AMI. So you're basically starting with a clean copy, starting from scratch again. And then they're also recording the incident response, making sure that they can follow the process, their incident response. They note that there was a malware found, and then the action that was taken, as well as the follow-up automated action that was taken as well. So another customer here that I just wanted to mention as a use case as well, this is a government healthcare agency, and they have a more complex environment where they're taking specific automated actions based on all different kinds of events as they're happening. So not just security events like the first use case, but they're actually taking events based on, say, operational tasks or all different types of things that are happening within the environment. And I'll show you just real kind of a simplified diagram of what's happening within this environment. So on the left-hand side, you have things like alerts, customers that have announced that they're having a bug with the application. They have, say, metrics that they're recording in the environment, as well as any patch or security news, vulnerability, releases that they need, zero-day threats, anything like that. It all comes into a pipeline in what we call Cyclops. And in this instance, Cyclops is just a name for a Lambda script that's doing normalized functions to basically take the data that's coming in from all these different applications and then make it into a readable format that can then be, say, put into a S3 bucket, analyzed with Amazon QuickSight for additional insights into the data, correlate the data, look at the data between what's happening in the current environment as what's happened in the past, and being able to actually do this all in real time and then push out IOC information out to, say, AWS WAF, or if they need to, say, make a change within the deep security that's protecting their EC2 instances, automatically make an API call to make those security changes and push out a rule set as well. So pretty complex in what they're doing, but it also allows them to, say, automate the entire structure of not just their operations as well as their security. And basically, this is the, I say, ideal use case for that Fastlane implementation. So siphoning all of the different events as they're happening from all different types of events, not just security again, and then basically taking action against that as needed. And what this comes down to is resiliency and building the resiliency in your workloads. So I talked first about kind of automating and the operations of automating within an AWS environment. I'm going to spend just a couple minutes now just talking about the security of the actual EC2 instances that you're building out in AWS itself. So things are going to happen within your environment. You might have an instance goes down. So we want to make sure that we have the correct security tools in place, again, to actually help build that resiliency that you currently have with those EC2 instances. So you might have a traffic flow of 443 going into each of your instances. And what we want to do is implement an intrusion prevention software that allows, say, we can actually do protocol cleansing. You can look and say, is the traffic that's coming in on this particular port, in this use case 443, is this good HTTPS traffic? So in this particular graphic, you can see that this is a good packet. It's sent on its way. I got a little bit of artifacts, but the idea is that this HTTPS packet is shown as being good, and it's let through the intrusion prevention as it's looking at each packet as it's coming in. And as I mentioned, you have a SSH packet that comes through on HTTPS port that we're only looking at accepting web traffic. We can actually drop the SSH traffic right here in the intrusion prevention to really, again, do that protocol cleansing. We're only allowing the HTTPS traffic internally. And then finally, you might have a HTTPS packet that has a SQL injection built into it as well. We can detect that code and then again drop that SQL injection traffic from harming your EC2 application. So we have also a different build environment. So you have both static or dynamic builds. And what I mean by that is, are you baking your tool sets into, say, an AMI image to be deployed out to EC2? We have several, I would say it's almost a 50-50 split on how our customers are deploying. And then the other side being dynamic. Are you using, say, Chef, Puppet, Ansible, OpsWorks to dynamically build your applications as the EC2 instances is built? And again, dynamically building all of the tools required, all of the applications, as well as dynamically assigning the security policies as well. And Gardner has a really kind of cool quote specifically around this, whereas in the days before cloud, you always had a secure network of workloads where on the outside you had your IPS, then your firewall. You had layers and layers of this perimeter security. You might even have some, IPS devices between maybe your campus and your data center. But it was always about securing the network, which is basically securing the workload from any of this, bad traffic that might be moving around. However, now we're moving into a state of a network of secure workloads where you actually secure the workload itself, so it doesn't matter where they move, whether it's a virtual machine that's now moved up into the cloud. You don't have to worry about, the outer perimeter security being in place or not. The security is actually built directly into that workload. And one of the ways also to accomplish this resiliency is using a blue-green deployment model. And what this is you have a deployment model where you have your production that's running on one side, and then everything that you want to test or make changes to is on the backup side. So you might have also heard this as AB deployment, no patch deployment model. Netflix called it red-black, right with their colors. But we'll just stick with the blue-green. And then, so what happens is you have a production on the blue side. It's running your production, and say these are Windows machines, and you want to reboot them. So you wouldn't actually reboot the production. You would actually bring up, say, a sample or the same exact images on your green side, make the changes that you would like to make, whether that's, say, an application change, maybe you want to update the rule sets for your intrusion prevention policies. Basically any change that you want to do, you can make that change on the backup side, or in this case, the green side, do all your testing, and then actually promote it to production. So you could use, say, you could use the load balancing, connection draining, which will actually drain connections out of one side into the other. It's a great use case there in using the elastic load balancers within AWS to actually accomplish this. So after you have both sides running in production, then you're just going to get rid of your old production side, and then you're really just going to go back and forth. After you destroy these, if you need to, say, make an additional change, you'll build a new application, make that application change, apply any patches, and then again switch it back over to production. So what you have is this environment that can scale back and forth between blue and green deployment models in allowing the no downtime patch, also called no patch environments, where you can effectively manage changes within your environment without affecting your customer presence, in this case, say, a web server environment. So one of the other controls that's really required in a cloud environment is making sure that as things are changing within an environment that we're tracking and making sure that we're alerting to anything that's suspicious within an environment as well. So you might have changes within, say, your cache or, say, your, the log files of specific applications. But one thing you wouldn't want to see changed is, say, a configuration file, because that should all be done on the back end, or that, the green side, the place that's not in production. Any change to the configuration files, say, operating system files, you really don't want those to be happening in a production environment. So you need to be alerted in real time that these changes are actually happening. So with an integrity monitoring control, we actually give you that ability to give you the visibility into things that are changing and alert you to things that are changing, maybe suspiciously as well. And finally, one of the other security controls that are great for a cloud environment and building this fabric is the ability to do application control for a server environment. And I say server environment because what we're expecting is when an application control is installed on a server, we want to we know that every application on that server is good. So by automatically whitelisting everything on that server once it's installed, again, Bluegreen deployment, we're doing it directly from the AMI. We know that everything is clean. And then what we can do is actually do with our CI/CD integration is actually as you're pushing changes, say if you're implemented Jenkins, you can have Jenkins actually notify deep security, add new files or new changes that are being made to automatically do that continuous deployment and continuous integration with your applications as you're making changes as well. So that really brings it back to resiliency and building this resiliency into your security fabrics that you're building within an AWS cloud. Again, the security fabric, we want to make sure that we're automating any operations or security tasks. So we can look at those in near real time and make sure that any actions that are too quick for a human to make, that we're actually doing it specifically within the automation tools available within AWS. And then again, I talked about security controls that can be put onto your existing EC2 instances that'll really give you that secure protection that you need for those workloads, as well as offloading the event pipeline out into AWS so you can make those same automated decisions based on your security as well. So that finally brings me to just a wrap-up slide with the Trend Micro Deep Security solution. Again, a full open API. We're doing all of our event pipeline notification through Amazon SNS, as well as a number of other SIM vendors, whether that's Splunk, Sumo Logic, QRadar, a number of others. We are already in those dashboards for all of the SIM vendors as well. So very easy to get the security events out of this tool. Remember, I had the slide previously of data in, data out, making sure that you can orchestrate it. So anything that you can accomplish within the Deep Security console, you can actually do via an API call. So very strong in allowing that automation to take place for a security tool that might be involved within your, that secure fabric within an AWS cloud. So I talked about the intrusion prevention, the integrity monitoring, the application control. Of course, anti-malware is included as well. This is an agent-based solution, and this is just a single solution platform. So each one of these security controls can be added to the agent. It's not running multiple agents. This isn't multiple solutions packaged together, but a single agent that's providing all of these different security controls. Other things I didn't mention is if you're running, say, Docker or other containers, we can also protect the Docker host as well as the containers with the deep security intrusion prevention, anti-malware. So really great, again, story there for any of the container usage, specifically with Docker or others. And that's all I had for today, Kim. I will hand it off to you. If there is any questions in the audience, I'd be happy to answer any of them.
Awesome. Thank you so much, Jason. Great information. As a reminder, if you have questions about today's session, please post them to the questions pane. And we do have a couple coming in, so we'll dive into those, Jason. First question, can you create the same solution on other clouds like Azure or Google Cloud?
So that's a great question. So what I demoed or showed here today was specifically around AWS Lambda and different AWS functions. There are similar things that you can do and accomplish within Azure and Google Cloud platforms. So for example, they have what's called functions, which is their same thing as Lambda functions, where you could say take automated or serverless approach based on things that you're seeing in different events. So it's certainly possible, but it's not something that I showed here today in that presentation. But we could be seeing other types of clouds also be involved in this level of automation by introducing additional services as well.
Excellent, thank you. We're right at the half-hour mark, but we'll squeeze one more question in. Can you implement an SIEM solution as part of this flow as well?
So that's great. So the SIM, I mentioned it a bit with the Splunk and different integrations there. But certainly if you wanted to, say, take actions against the events that are coming into a SIM as opposed to, say, directly from SNS using Lambda, certainly that would be a workflow you could do as well. So there's a number of tools that integrate directly with SIMs where you can, say, take automated approaches specifically on the data that's coming into a SIM as well. So that's also a well-known practice that a number of our customers are doing as well, is taking the automation, or excuse me, taking the event flow into the SIM solution and then using the separate automation tools if you didn't want to process it all within a cloud environment.
Great, thank you.